Welcome to the debate.
Thanks for having me.
So today we're digging into something that happened recently, August 14th, 2026.
Right.
And honestly, it was a bit of a quiet earthquake in the AI landscape. Z.ai, which is the international arm of Tsinghua University's Zhipu AI, they launched GLM-5.3. And you know what makes this launch genuinely historic is that it wasn't this massive leap in raw computing power or a radically new architecture.
No, not at all.
The mystery here is how an AI got drastically smarter without actually learning any new foundational information.
Exactly. They didn't train a new model from scratch here. GLM 5.3 uses the exact same base model as its predecessor, GLM 5.2.
Right.
So we are talking about a massive 743 to 753 billion parameter architecture.
Yeah.
But the real catch, is that it achieved this generational leap in capabilities in just 1 month.
1 month. And that 1 month was dedicated entirely to post-training scaling.
Yes.
So no new text ingestion, no scraping the broader internet, just strictly teaching the model how to better use the knowledge it already had.
Right, and that's the core of what we're looking at today.
Exactly. So today we are debating the profound implications of this. Does GLM 5.3's pure post-training strategy and the sudden, emergent cybersecurity capabilities that it unlocked, does that represent a triumph of open weight efficiency, or does it expose critical, uncontrollable risks and massive bottlenecks in how we scale and release open source AI?
I argue that GLM 5.3 proves post-training scaling is the ultimate efficient equalizer for the open weight community, and that its emergent capabilities are a net positive, managed responsibly by Z.ai. And I take the opposing view. While the raw performance gains in coding they're undeniably impressive, the accidental emergence of exploit chain reasoning highlights a systemic unpredictability in post-training. It exposes severe governance vulnerabilities, as well as these hidden human labor bottlenecks, which suggest the open source community is simply not ready for the kind of power that just got unleashed.
Okay, well, let's start with the sheer economic and technical efficiency of Z.ai's approach, because I think it fundamentally rewrites the playbook.
Okay.
For years, the assumption was that to get a smarter AI, you had to build a bigger engine. You had to push more pre-training compute at the cost of hundreds of millions of dollars.
Sure.
But look at what Z.ai did here. They used a mixture of experts, or MOE architecture.
Which is a crucial detail to understand. Out of those 750 billion parameters, only about 40 billion are active during any given inference.
Right.
It's like a massive corporation with, 750,000 employees, but for any specific task, you only call on the 40,000 specialists relevant to that exact problem.
Precisely. It is highly efficient at the point of use. So instead of building a new engine, Z.ai took a fully built world-class Ferrari, which is the 5.2 base model, and they spent a month strictly tuning the telemetry, refining the gearbox, calibrating the brakes.
Mm-hmm.
And they did that through reinforcement learning, or RL. They put the model in verifiable environments and basically rewarded it for thinking through complex, long-horizon coding tasks.
Right.
And the result?
The model dominates in agentic coding tasks among open weights, not because it read more code, but because it was optimized to reason perfectly through the code it already knew.
It is a beautiful process to watch on a technical level. The engineering precision required to tune a machine to its absolute limit is staggering. But I come at it from a different way.
Okay, your Ferrari metaphor works for efficiency, but let's talk about emergent behavior. It's more like you taught a locksmith how to build the absolute perfect unbreakable lock.
Sure.
They practice and practice until they understand lock mechanics flawlessly. But by doing that, you've inadvertently taught them exactly how to pick any lock in existence.
Well,
When a model doubles its performance in vulnerability discovery, almost accidentally, it reveals a terrifying lack of fundamental control.
See, I don't see it as a lack of control at all. I see it as a structural realization of capability, and we completely understand the mechanics behind it. Let's look at the actual coding leaps achieved using their existing tech stack, which is what enabled all of this.
Okay.
They used index share, which allows the model to manage a massive 1 million token context window.
Right.
That's essentially keeping 1,000,000 words in active short-term memory without losing the plot.
Right, and they paired that with the SAO framework, which is designed for long horizon RL.
Exactly.
This means the AI can take a prompt that requires hundreds of sequential steps to solve and map it out over time.
Yes, and to speed it all up, they used a framework called SLIME for asynchronous training, allowing the model to learn from multiple different coding environments simultaneously without waiting in line. The synergy of this stack yielded results that are frankly hard to overstate. Take Terminal-Bench 3.0.
A notoriously difficult benchmark.
Brutally difficult. Terminal-Bench 3.0 isn't a multiple-choice test. It's a blank command line interface. The AI has to act like a real software engineer navigating a computer terminal to fix a broken system.
Yeah.
GLM-5.3 jumped from a score of 4.6 to 28.3.
Which is over a 6-fold improvement.
Exactly. And their internal Z.ai Code Bench improved by 50%. I mean, this definitively proves that pre-training is no longer the main battlefield. Post-training is where the true value lies.
Yes, Terminal-Bench 3.0 saw a 6x jump, but you were looking strictly at the output. We have to talk about the bottleneck of the input. How exactly do you think those reinforcement learning environments are created?
Well, they're verifiable environments where code is executed and tested.
But tested by what?
Well,
By unit tests and parameters written by humans? To get a model to improve via RL, it needs a reward signal. In coding, that means creating complex sandboxes where the model's code can run, compile, and be tested against edge cases to see if it actually works.
right.
Right now, generating and verifying these environments at scale relies heavily on manual human labor. Pre-training is easy, you just scrape the web and feed it in, but RL requires senior human engineers to define the precise parameters of success for incredibly complex tasks.
But that's exactly why Z.ai's achievement is so remarkable. They optimize the process.
They pick the low-hanging fruit of environment creation. Once you move past what is easy for a human to sandbox and verify, once the AI is writing code more complex than the human evaluator can quickly write tests for, how does this approach scale?
I mean,
There is a hard ceiling on this scaling method. The open-weight triumph is far more fragile than the headline metrics suggest, because we will run out of human ability to write complex tests long before we run out of computing power.
that's an interesting point, though I would frame it differently. You're focusing on a theoretical labor bottleneck, but look at the token efficiency data we are already seeing.
Okay?
On the high-effort reasoning setting, GLM-5.3 achieves a 31.4% success rate on these tasks, using only about 50,000 output tokens.
Which is a measure of how much it has to think out loud to reach an answer.
Right. Compare that to the proprietary Claude Opus 4.8, which achieved a 29.5% success rate, but required 120,000 tokens to get there.
Wow.
GLM 5.3 is achieving a higher success rate while doing less than half the computational thinking. The environment creation might be human-led right now, but the model's ability to internalize the logic and operate efficiently within those parameters is entirely automated. It learns the pathways of success so well that it doesn't need to brute force the generation. That efficiency is the breakthrough.
Wait, let me stop you there. You are presenting fewer tokens as a pure victory for efficiency. But fewer tokens doesn't mean it's safer or simply better.
Why not?
If a model takes half the computational thought to navigate complex logic, it means it is becoming highly efficient at bypassing obstacles without leaving a trace. That learned pathway of success is exactly the mechanism that causes the unpredictability.
How so?
If it solves a coding problem faster, it's just a better coder.
Think about what coding really is at its core. It's navigating logic within strict rules to achieve a specific outcome. When you push a model to aggressively seek successful pathways in complex, long-horizon coding tasks, you are fundamentally rewarding it for finding loopholes. Oh, I see where you're going.
You are training it to manipulate systems and chain logical steps together to reach the goal, regardless of the obstacles. Hacking is just coding with malicious intent.
Right.
It's finding logical loopholes in a system's constraints. Pushing reinforcement learning to overcome coding limits is precisely what led to the model's unpredictable behavior. You aren't just making a programmer, you're accidentally training a hacker.
Which I see as a massive win for open source defense. Let's look at the cybersecurity findings that emerged from this. The model achieved an 84.5% on CyberGym, which measures white box vulnerability discovery.
Right, meaning the AI looks directly at the source code to find the flaw.
Yes, exactly. That score beats Mythos 5, and it beats GPT 5.6 Sol.
Finding a bug in white box testing is impressive, I'll admit.
It's more than impressive, it's practically transformative. Z.ai unleashed this model in real-world tests alongside Chinese security teams, and it found 2,436 vulnerabilities across 269 open-source projects.
Yeah.
And we aren't talking about trivial theoretical bugs. 1,097 of those were medium to high severity, sitting in legacy code bases that are up to 40 years old. Having an open weight model capable of autonomously auditing global digital infrastructure at that scale is a monumental triumph.
I'm sorry, but I just don't buy that. Let me tell you why. You are focusing on the discovery of isolated flaws. Finding a buffer overflow in 40-year-old code is great for defense, yes? But if that were the extent of it, we wouldn't be having this debate.
Okay.
The post-training scaling didn't just teach it to spot an isolated error. It sparked the emergent ability to reason about full exploit chains.
And an exploit chain is just the sequence of steps an attacker takes to fully compromise a system.
Exactly. Step 1, find a tiny vulnerability to get a foothold. Step 2, use a privilege escalation flaw to get admin rights. Step 3, execute a sandbox escape to take over the entire server.
Right.
Look at the exploit bench scores. They more than doubled, jumping from 24.4 to 54.4. The engineers didn't explicitly train it to chain attacks together.
No.
The model figured out how to do this entirely on its own because, as we discussed, RL rewarded it for finding complex logical pathways. Discovering a 0 day is one thing. Independently reasoning through how to chain that vulnerability to fully hijack a server is an entirely different, highly dangerous threat profile.
But that threat profile is exactly what our legacy systems need right now. The ability to reason through an exploit chain is fundamentally necessary to understand the severity of a vulnerability. You cannot adequately defend a system if your defensive tools can't comprehend how an attacker might chain exploits together.
Well,
The fact that the model learned this through coding RL just shows how interconnected deep coding capability and cybersecurity genuinely are. It's providing defenders with the mindset of the attacker.
it shows that we don't fully know what we are building. Z.ai introduced data and vulnerability environments as part of the post-training, and they themselves explicitly stated they were surprised by the rate at which these exploit chain capabilities appeared.
Yeah, they were surprised.
That is the very definition of emergent and uncontrollable. And we have to be honest about where the open source ecosystem actually stands right now. Yes, GLM-5.3 crushed white box discovery, but there is still a significant gap in deep exploitation, which is measured by CyberGym compared to proprietary closed models.
Meaning the top-tier closed models from the biggest tech giants still hold the crown for actually executing complex hacks?
Precisely. And that gap between open weights and frontier closed models in deep exploitation is arguably the only thing keeping the current open source ecosystem somewhat safe today.
I don't know about that.
Well, if a single month of post-training can double exploit bench scores accidentally, what happens when someone forks the open weights and runs their own RL pipeline focused solely on offensive exploitation?
I see why you think that, but let me give you a different perspective on how Z.ai is actually handling the reality of this dual-use technology. Because they didn't just dump the weights onto the internet the minute they realized what they had.
No, they didn't.
They established a highly responsible scientific release strategy. First, they created the public Z.ai Security Disclosure Ledger to transparently track, report, and patch the vulnerabilities the model found before anyone could exploit them.
A ledger is great, assuming the maintainers of those 40-year-old projects have the time and resources to actually implement the patches.
It's a necessary first step. Second, they prudently delayed the release of the open-source MIT licensed weights until late August 2026 to complete rigorous safety hardening and alignment. They took the time to secure the tool.
Right.
And crucially, they did all of this while maintaining commercial accessibility. They kept their API prices incredibly low, at around $1.40 per million input tokens.
Yeah.
This proves that the open source community can self-regulate, secure infrastructure, and maintain democratization all at once.
A 2-week delay? You're holding up a 2-week delay as the gold standard of responsible governance? I have to strongly challenge the adequacy of that.
It was enough time for post-training alignment.
Is roughly 14 days of safety hardening genuinely sufficient for a model that spontaneously developed the ability to reason through multi-step server exploits? Because once you release those weights under an MIT license, the cat is out of the bag permanently.
Safety hardening in post-training is highly effective, though. You use the exact same RL infrastructure that built the capabilities to penalize malicious output. You teach it to refuse to write the exploit chain.
But that exposes the massive, glaring flaw in the entire open-weight paradigm. What does it mean to release an open-weight model? It means you are handing over the underlying mathematical matrix of the AI.
Right.
Once the weights of a highly capable, post-trained model are public, any alignment or safety safeguards baked into that model can be systematically stripped away by bad actors.
It takes effort to undo alignment. It's not trivial.
It takes a fraction of the cost of training. It doesn't take massive pre-training compute to undo safety guardrails. It just takes a small data set of malicious examples to fine-tune the safety penalties right back out of the weights.
Well,
By releasing this, Z.ai is creating a massive asymmetry. The offensive capabilities will be stripped of their safeguards instantly by bad actors. Meanwhile, the defensive readiness of the millions of organizations running those vulnerable, 40-year-old open-source projects will take years to catch up.
that asymmetry already exists. But right now, it currently favors the state-sponsored attackers and cybercriminals who hoard 0 days and have the budget to use proprietary AI to find them.
That's true.
GLM 5.3 flips the script. Yes, someone could try to strip the guardrails, but simultaneously, every security researcher, every underfunded open source maintainer, and every IT department now has access to a frontier-level cyber auditor.
Right, but
The defensive community operates at scale and in daylight. By providing this tool as open weight, Z.ai is ensuring that the defenders are finally armed with the exact same caliber of intelligence as the attackers.
the defenders operate under the crippling constraints of bureaucracy. They have patching cycles, legacy system uptime requirements, and compliance reviews.
Sure, yeah.
If an AI tells an IT department about a vulnerability, they can't just reboot the hospital server at 2 p.m. on a Tuesday to fix it.
I mean,
The attackers, on the other hand, operate without red tape. Giving both sides a tool that autonomously reasons through exploit chains inherently favors the side that only has to be right once, rather than the side that has to patch everything everywhere perfectly.
the alternative is leaving the defenders blind while attackers build their own models anyway. Our governance models are adapting exactly as they should to technical reality. Z.ai recognized the emergence, paused the weight release, documented the vulnerabilities via the ledger, and released the model in phases.
Yeah.
That is the scientific method applied to AI deployment in real time.
But again, this all circles back to the core issue. This capability was an accidental byproduct of pushing reinforcement learning to overcome a coding benchmark. If we are relying on an ecosystem where our most powerful cyber weapons are essentially the exhaust fumes of coding tests, our governance models are completely detached from technical reality. We aren't proactively managing risk, we are reacting to accidents.
I think reacting effectively to emerging capabilities is the hallmark of good science. And we have to look at the broader implications for the field, which are profoundly democratizing. If you look at the recent literature, like the widely discussed ACL 2025 survey on post-training scaling,
Great paper.
it really is. The consensus is clear. We have reached a point where the massive base model is merely the raw material. The fact that a lab can take a 750 billion parameter MOE model, activate only a fraction of those parameters at a time, and use one single month of RL to rival the most expensive proprietary models on Earth is a total paradigm shift.
Right.
It means the monopoly on frontier intelligence held by massive corporations is breaking.
I will readily acknowledge that we have definitively shifted from the era of pre-training brute force to post-training precision.
Yeah,
The ACL 2025 survey makes that abundantly clear, and Z.ai's architecture here is undeniably a technical marvel. But the democratization of intelligence is inevitably the democratization of risk.
Okay.
The manual bottlenecks of generating quality RL environments mean that as we push these models harder to squeeze out that post-training efficiency, we are going to rely on increasingly complex automated reward systems. And as we've seen with GLM 5.3, when the model learns to game complex systems, it learns to hack.
Right.
We need a far more cautious approach to open sourcing these post-trained weights, because the line between a brilliant coding agent and an autonomous cyber threat is apparently just 1 month of reinforcement learning.
As we synthesize our perspectives today, my position remains that GLM 5.3 is an absolute masterclass in post-training efficiency. It proves that tuning the Ferrari rather than rebuilding the engine from scratch is the most viable, economically sound path to democratize frontier-level coding and defensive cyber tools. Z.ai's phased release, their low API costs, and their public vulnerability ledger show that open-weight labs can operate at the cutting edge without sacrificing responsibility.
And my position remains that the entirely accidental nature of these exploit chain capabilities demands a serious pause. The manual human bottlenecks inherent in creating RL test environments suggest this scaling method is fragile. Furthermore, the sudden emergence of dual-use cyber threats proves that a 2-week delay on open weights is woefully insufficient for the kind of power we are dealing with.
Right.
Especially given how easily safety guardrails can be stripped away.
We have explored a lot of complex terrain today, from the mechanics of mixture of experts to the underlying logic of exploit chains. But one point of absolute convergence between us is that the landscape of AI development has forever changed.
Absolutely.
The era of simply throwing more GPUs at a pre-training cluster is over. Post-training precision is the new frontier. For those of you listening who want to dig deeper into the mechanics of this shift, I highly recommend exploring the academic literature on post-training scaling, particularly the ACL 2025 survey we mentioned.
And I would strongly suggest keeping a very close eye on the Z.ai security disclosure ledger over the coming months to see just how many of those 40-year-old legacy bugs actually get patched.
Indeed. We'll leave it to you to decide whether the open weight community is truly ready for this level of emergent power. In the end, we're left with a lingering question. When you teach a system the perfect mechanics of optimization, are you creating a better tool for everyone? Or are you just teaching the machine exactly how to pick the locks on our digital infrastructure?